Welcome back. We are going to solve rational equations today, and if you follow these steps, it's really not that bad. So the first thing you want to do is find your domain restrictions. So if you look at this problem, you see the only issue would be if you had a 0 in the denominator. So we know our domain, x cannot be equal to 0. Now that'll be helpful in a little bit. So now we have to find our least common denominator. And for this, it looks like we can turn a 2 into a 2x and an x into a 2x. So our LCD is 2x. So part C, we have to multiply the numerator by what we need to get our common denominator. So this needs a 2 to make it 2x, so top and bottom. This needs an x on top and bottom to make the denominator 2x, and this denominator needs a 2, so we multiply 2 to the top and bottom. So how do we solve? To solve, what we do after we have this all lined up is we get rid of the bottom for solving purposes, and we just use the numerators. So we have 8 plus 5x is equal to a negative 22. And now we just solve for x. Subtract your 8. 5x is equal to a negative 30. So x is equal to a negative 6. Now we just need to write our solution in set notation, and we need to check to make sure we don't have any extraneous solutions. So our only solution that we have is a negative 6. Is that something that x cannot be? Just go back and look at your domain. The only thing x cannot be is 0. So in this case, negative 6 works. So your solution is negative 6 in your squiggle brackets. There are no extraneous solutions, so right there, you are done. That's it. So let's do another example. In example number 2, the first thing we're going to want to do is, again, state our domain. So if we look through here, the only thing x is not allowed to be is 2. So x cannot equal 2, because if we put a 2 in, we'd have a 0 in the denominator. Our LCD is going to be x minus 2. So the only thing this needs is an x minus 2. So we need to multiply the top and bottom by x minus 2. And here goes that step where we have common denominators. We can get rid of the denominators and just solve the equation. 5x is equal to 7x minus 14 plus 10 by distributing that 7 into there. And combine our like terms and solve. So we get a negative 2x is equal to a negative 4. So x is equal to 2. Now we just check with our domain. Our domain says that x is not allowed to be 2. We have no other solutions. So our final answer is no solution with an extraneous solution of 2. And you're done. It's just like solving back in the day, except for we have to get a common denominator first. But once you get that common denominator, you can cross out your denominator and go to work on the top. So number 3, you're going to need to do just a little bit of factoring really quick with the 6 over x squared minus 4, because that is a difference of 2 squares. But I would like you to pause this video, and I would like you to see if you can handle this problem on your own. Go give it a try. If you got 1 and negative 3, you are good. So the first thing you had to do, like I said, is factor this. It's the difference of 2 squares, so you have x plus 2 and x minus 2. So that means your LCD is going to be x plus 2 and x minus 2, and your domain, x cannot equal 2 or negative 2. So this is where you multiply your numerators and your denominators by what you need to make the LCD. So this first fraction needs to be multiplied by x plus 2 on the top and bottom. This is all good, and this one needs to be multiplied by x plus 2 and x minus 2, which we know is x squared minus 4. So from there, you FOIL this left, and you get 3x squared plus 6x minus 2x minus 4 equals, and we have 6 plus our x squared minus 4 when we FOIL these back together, and we have this equation. Now you just need to combine like terms and get everything to the left, so it's set equal to 0. factor out your GCF of 2, factor this, and you get x minus 1 and x plus 3. So you check 1 and negative 3. 1 and negative 3 are totally allowed by the domain. The only thing that's not allowed is 2 and a negative 2. So you're good to go, and this problem is finished. Okay? So that's that. Now there's 2 more examples in these notes, but they're slightly different. This is when you have one fraction on both the left and the right. So what you're still going to need to do is you still need to list your domain. So in this case, x is not allowed to be 1 or 0. Now where did I get the 0? Well, if you look over here, we can factor out an x. So you factor out an x here just so you can see your domain. But you do not need to get common denominators here because you only have 2 fractions. You can just use a good old-fashioned cross multiplying to solve this problem. So you would just cross multiply here. So we have 2 times x minus 1, and that's going to give us 2x minus 2 equals, and now we have x squared minus x times 1, which is just x squared minus x. You can see what you need to do from here. Get everything over to the x squared side. So we have x squared minus 3x plus 2, so we can set that equal to 0. We're going to factor here. We're going to have an x minus 2 and an x minus 1. So we get x is equal to 2 and 1. So now we need to go back and check the domain. X is not allowed to be 1 or 0. So our final answer is x is allowed to be 2, but not allowed to be 1. So there you go. That's it. You still need to list your domain so you can check with your domain, but you do not need a common denominator when you only have a fraction on the left and a fraction on the right. So this one's yours. Pause the video and give it a try, and we'll check back in a minute. So if you have a solution of 3 and an extraneous solution of a negative 4, you again are good to go. You had to factor the bottom left just for your domain purposes. And once you do that, you just have to cross multiply. X squared times 4, or x squared plus 4x times 1 is x squared plus 4x. 3 times x plus 4 is 3x plus 12. Bring everything to the x squared side, factor, solve, check with your domain. You're good to go. Last video of the chapter. This is Longo and I'm out. See you. Bye.